Welcome back. As extremes of thought experiments, we can imagine a market with perfect competition, or a market with no competition at all. In reality, the markets we see have different degrees of competitiveness, but they all lie in the spectrum between these two extremes. In previous videos, we discussed one extreme, perfect competition, as an important benchmark. In this video, we expand on the firm's problem in the perfect competitive market to analyze the other extreme market structure, monopoly. We will first look at the profit maximization problem under monopoly. Our monopoly model has one and only one difference from the model of perfect competition. The residual demand facing each firm in a perfectly competitive market is perfectly elastic, or horizontal on this graph. The demand facing a monopolist is exactly the market demand, which is downward sloping. These differences in the demands have different implications when it comes to the firm's output decision. The implication of the horizontal residual demand is that marginal revenue is equal to price for a firm under perfect competition. When the firm is a tiny participant in a very large market, such as under perfect competition, its output level barely moves the overall market outcome, so the price does not change at all as its output varies. As a result, when the price is at P1, as illustrated on this graph, each unit of additional output by the firm will simply raise an extra P1 into the revenue. In other words, the firm does not worry about changes in the price when they decide whether they want to produce an extra unit of good. You will notice that we use a little q here for the quantity in this competitive equilibrium situation, because the market output is the sum of all individual outputs. Under monopoly, however, the firm's output is the market output. So we denote the output by the monopolistic firm using the capital Q here. Because the firm faces a downward sloping demand curve, and the firm's own output is the entirety of the market output, so the marginal revenue is no longer equal to the price. And it is entirely because of the downward sloping demand facing the firm. As the firm produces more or less, the price changes with it, creating an additional concern for the firm. To see how it works, let's imagine that a monopolistic firm produces an output level of Q units here, and the market price is at P1. In this case, the firm's revenue will be P1 times Q, or the entire area of A and C combined. If the firm decides to produce one additional unit from Q to Q plus 1, then the market price will drop to P2. So what happens is that the firm will earn revenues from this additional unit of output, but the lower price driven down by this additional unit of output will reduce the revenue for all of the outputs, not just this additional one. The revenue with this additional unit of output will be the area of A and B combined, with a wider base but a lower height. In comparison, the new revenue for the firm will gain by the green area marked by B, but loses by the area marked by C, because the width of this green rectangle is only 1 unit. So the area of B is exactly the price level of P2. Therefore, the marginal revenue of the monopolistic firm is the area P2 minus the area of C here. This impact is greater if the output level is higher, meaning a larger width of this area C, or if the demand curve is steeper, meaning a larger drop in price going from P1 down to P2 as the output level increases by 1 unit. In an extreme case, if the area C is bigger than the area B, then the firm's revenue can in fact decrease with more output. The key insight here is that the decreasing demand facing the monopolist adds an additional concern when the firm considers increasing its output level, because the additional output level pushes down the price and hurts all units of output. So under monopoly, the marginal revenue is actually lower than the price. In other words, the marginal benefit for the firm to increase production is now lower. We can see this insight from the algebraic perspective. The key idea that leads to the algebra is that the demand facing the monopolist is the market demand. The marginal revenue is still just the derivative of the revenue with respect to the output level. And the revenue is still the product of price and quantity. These things haven't changed at all compared to the perfect competition. What is different, however, is that the price is now a function of the output level, exactly because the downward sloping demand curve facing the monopolist. Now, as the output level increases, there are two effects. The extra unit of output collects additional revenue at approximately the price level. This corresponds to the gained area B on the previous slide. But the price level will actually decrease as the output level increases. As a result, it reduces revenue for all units of the firm's output level. This lost revenue is measured by the second term, which corresponds exactly to this area C on the previous slide. And the derivative measures the decreasing price, which is the height of the rectangle, from P1 to P2. And Q measures the base of this rectangle. As a result, because the demand curve is downward sloping, this derivative of price with respect to output is negative. Therefore, the marginal revenue is equal to the price minus a certain amount. Therefore, it is going to be smaller than the price or the marginal revenue under perfect competition. More precisely, notice that the second term is a function of the output level. So the marginal revenue on the monopoly is no longer a constant, but usually a curve that changes with the output level. In particular, you were told in the principles class that the marginal revenue curve with a linear demand function on the monopoly will cut the demand curve in half on the horizontal axis. We can derive this result just by taking a derivative, and I will leave that to an exercise. In the principles class, we learned about the profit maximization problem graphically. We know that the firm will choose an optimal output level that satisfies marginal revenue equal to marginal cost. The condition we previously derived under perfect competition. So on this graph, the firm will choose an output level of 6 units, where marginal revenue and marginal cost curves cross each other. At this output level, the price would be determined by the demand curve, which is at $18. And at this level of output, the average cost would be determined by the average cost curve, so that will be $8. Therefore, the average profit on each unit of output is going to be $10, and so the total profit would be $60. This result follows easily from a more formal algebraic model. Now let's take a look through an example. Let's say that we have a monopolistic firm faces inverse demand, which is P is equal to 24 minus Q. So this is a linear demand function. And the cost function is C is equal to Q squared plus 12. Then what is the firm's profit maximizing output level Q star and its profit level of pi star? we'll follow exactly the same steps in solving the profit maximization problem under perfect competition. We will first write down the firm's profit function, and then take a derivative to solve for the optimal output level through the first order condition. The optimization problem is to maximize the profit, which is just the revenue minus the cost. The difference here from the perfect competition is, again, that the price is now a function of quantity. So, with this objective function, we take derivative with respect to the output level. And that gives us marginal revenue is equal to marginal cost. The marginal revenue term is exactly what we saw 2 slides before. With the specific demand and cost functions here, we can now plug them into the first order condition. The derivative of the inverse demand function with respect to quantity is -1. And we can multiply that by Q plus the inverse demand function plugged into this slot. And the marginal cost is the derivative of the cost function with respect to Q, which gives us 2Q. Given these expressions, we can simplify a little bit by collecting the term of Q on both sides of the equation, and that will solve and give us a Q star equal to 6. We can now plug this quantity back into the demand to find the price level at this output level, which is going to be $18. And we can plug these results back into the profit function here with a price of $18, a quantity of $6, and this cost function, which has a cost of 48 units. When the output is at 6, the profit is at 60. This example illustrates how to solve the profit maximization problem under monopoly. The process is quite straightforward. I will just note that the key driving force of the model lies in the fact that the price is a function of the output level. And it brings a world of difference between this model and perfect competition. Because the marginal revenue under monopoly is lower than that under perfect competition, the firm's optimal choice is to choose a lower output level. This leads to inefficiencies in the market. We see here that given the same marginal cost, a firm in the perfect competitive market would have chosen a higher output level, QC, that corresponds to the competitive equilibrium. And the price will be equal to the marginal cost. But under monopoly, the firm will choose a lower quantity, QM, where the marginal revenue under monopoly is equal to the marginal cost. Given this lower output level, the price at PM, which is 18 units, the price is higher than a competitive level of $16. With the higher price, the consumer surplus is only the area of A, instead of A and B and C combined under the competitive outcome. The producer surplus on a monopoly is B and D combined, as opposed to D and E combined under perfect competition. So overall, at the market level, the surplus of C and E are completely lost, which is the deadweight loss. In this video, we covered the monopoly's profit maximization problem. The key takeaway is that the monopoly has incentive to produce less than the alternative under perfect competition because the marginal revenue is lower than the price. And this is driven by the downward sloping demand curve facing the firm. Consequently, the higher price and lower output compared to the perfect competitive market leads to inefficiencies.